This is the homocysteine methylation cycle. There are actually two of them interlocking, as you see the arrows are suggesting. And we see the methionine at the top gives rise to the homocysteine right there at 6 o'clock. And then the homocysteine has to be remethylated back into methionine at the top of the cycle. So following the arrows in this clockwise direction, we see that methylfolate 5-MTHF combines and contributes towards the remethylation, the removal of the potentially harmful homocysteine. So now in the next go-around, look at how when the arrows hit homocysteine. Notice how the homocysteine actually goes down, around, and through the middle of the cycle. Let's take a closer look at that again. So you see that there are different routes that the body can have to remove the excess homocysteine to remethylate it. You can bring it back around to the top of the methionine cycle, but as we see here, that the homocysteine also goes down through CBS. It's going down into a pathway known as the transsulfation pathway. This is how we make cysteine. This is how we make glutathione through this transsulfation pathway. So the reality of the situation is, while we actually must have some homocysteine, because if we didn't make homocysteine, we wouldn't necessarily be able to make cysteine, and then we wouldn't necessarily be able to synthesize the amount of glutathione that we actually need. So it's kind of a double-edged sword. You need some homocysteine, but too much of it is problematic, and the literature clearly supports this reality. There are 5 major nutrient cofactors that will remove excess homocysteine. So if you see elevated homocysteines on a blood test, you'll want to be including these 5 nutrients in some amounts in your diet. These 5 nutrient cofactors are B12, 5-methylfolate, pyridoxal 5-phosphate, P5P, which is an active form of B6, trimethylglycine, also known as glycine betaine or TMG, and last but not least is choline. These 5 nutrient cofactors are the major promoters of homocysteine remethylation.